Space is the final frontier, according to Star Trek's Captain Kirk. Corrosion is not an issue that immediately springs to mind when thinking about outer space, but let's have a look and see if we should be concerned. Firstly, we need to recall that corrosion is a chemical reaction between a material, usually a metal, and something in its surroundings or its environment. A common example is where steel reacts with oxygen and water in the atmosphere to form rust. So how can we avoid such a chemical reaction occurring? We can prevent corrosion by removing the chemicals in the environment that cause corrosion. This can be achieved by travelling about 100 kilometres away. Up! Once in space, there's no oxygen, no water, no chemicals such as acids and salts, nothing that can cause corrosion. For proof of this, we just need to look at the condition of iron asteroids that circle the Sun. These are left over from the formation of the solar system billions of years ago. Most asteroids are rocky, but there are iron asteroids which are largely an alloy of iron with about 10% nickel and traces of other elements. They are still in their original state with just a tarnish from billions of years' exposure to the solar wind. There's no corrosion on these iron asteroids. Iron meteorites are small iron asteroids that have landed on Earth. This is a slice from one that landed in Sweden about 1 million years ago. The surface corroded during its time on the ground, but the interior is intact. Such meteorites can be considered as a piece of alloy steel that is billions of years old but is not rusted. Incidentally, the geometric etch pattern is known as the Widmanstätten structure and is the result of the extremely low cooling rate when the asteroids formed at the birth of the solar system. Such structures on this scale are not observed on earthly objects. But space is not entirely empty and can be extremely damaging. Temperatures can range from high enough to melt metals to close to absolute zero. Pressure can range from tons per square centimetre inside gas giants such as Jupiter to a vacuum in interplanetary space. Cosmic and ultraviolet radiation would damage any plastic or composite materials. The sharp, abrasive dust not subject to weathering found on the Moon would wreak havoc with any moving parts. And fast-moving micrometeorites can penetrate metal skins. So while corrosion, degradation by a chemical reaction, is not a major issue in space, this does not mean there would not be a source of serious damage to metals and other materials. Our sister planet Venus is perhaps the least desirable place to visit in the solar system. The Russians did manage to land the Venera probes on the planet's surface in the 1970s and 1980s. They passed through corrosive sulfuric acid in the outer atmosphere, but this was not the problem. Landing on the surface, they encountered temperatures of about 450 degrees C, hot enough to melt lead, and an atmospheric pressure 90 times that on Earth. They sent data back for up to 2 hours or so before being destroyed by the pressure. They would now be a crumpled mass of titanium on the surface. There are plenty of hazards for inanimate objects in space, but corrosion is not an important one. However, humans travelling to space face serious risks. We need water and oxygen to survive, and our activities will produce corrosives. So the little bubbles, spacesuits, spaceships or colonies we need to survive in space, on the Moon or elsewhere, will create potential corrosion problems for any metal or material we need to use. We can see this from the limited travel already made. Neil Armstrong's spacesuit that he wore when taking his historic first step on the Moon is one of our most important modern artefacts. Yet it suffered damage from the moon dust, sweat and poor handling and storage. Fortunately, conservators have restored it and is now on display at the Smithsonian Museum in Washington, D.C. A salutary lesson regarding hazards in outer space. So corrosion may not be an important consideration in space, but there are many other hazards out there that will destroy our metals and materials. My name is Rob Francis, and on behalf of the Australasian Corrosion Association, thank you for watching this short presentation.